Okay, so this is number 5E, number 4. We've got a little hurdler person who we have reduced to an insignificant speck of matter. We just reduced them to their center of gravity. So what we're interested in is their initial vertical speed. And of course, their vertical speed is up. So we're not concerned with their horizontal speed. We just don't care because we're only interested in their vertical motion. And that's the nice thing about these is we can completely ignore angles and all that other nonsense. So they have a VI of 2.2 meters per second. Of course, what that's ignoring is the fact that if you were doing this from scratch all by yourself, you'd have to break out the vertical portion of their motion. So it's been done for us, hence we can't ignore the angle. What we know is that the final ME equals the initial ME. So, okay, so what we're interested in, this is of course mass times gravity times final height, and that's what we want to know. The final kinetic energy, so it's 1/2 mvf squared. What's the final velocity at top of arc? If you think back to chapter 3, 0. It's the moment where upward motion stops and you start to move back downward, so that goes away, which is nice. The mass gravity initial height plus 1/2 mass velocity initial. What was their initial height above the ground? 0, so that goes away. So we actually have a really nice little setup here where final height is equal to 1/2 mass initial velocity squared divided by mass gravity. So mass goes away, and we end up with VI squared over 2G, basically. So for 5E, number 5, and we haven't really talked about pendulum bobs yet, but a pendulum bob is just a mass on a string attached to something. So for this mass on this string, if we're considering the bottom of the string, the bottom of the arc as far as it can fall, that's your arbitrary 0. So if we say that at this point VF equals 1.9 meters per second, and here VI equals 0, we're just solving for the height. So we know that at the bottom of the arc, height equals 0, and at the top of the arc, it's going to be some number that's not 0. Does that make sense? So H final equals 0, H initial is what we're looking for. So we're just plugging that, and here's our difference in height is right there. So ME final equals ME initial. Okay, so you've got this kinetic, this object, and you've got work done by the puller, work done by gravity, and work done by friction. If you add all those up, you get the net work. So if you add all these, you get the net work. And basically that's question D, because net work equals change in KE.
Okay.
Well, net work equals change in KE, and change in KE equals KE final minus KE initial.
Okay.
And KE final is 1/2 mass final velocity squared. Whoops. So then this is 1/2 mass initial velocity squared.
Okay.
Well, there you have final velocity to solve for, and it's equivalent to the net work, which, of course, you got in part D.
Okay, so you wouldn't plug in FD cosine theta.
You could if you used net force,
Okay.
but you've already figured the net work, or the delta KE, so you might as well just use that.
Okay, if I use net force though,